Okay, so let's remember that on our last test, we had the library function y equals x squared, which was a parabola. And a parabola has what we call a vertex. And let me draw here. A vertex. And the vertex right here is where the two symmetric sides of the parabola come together. So this is called our vertex. And of course, in the case of x squared, it is just the point 0, 0. But remember, on the last test, we also did transformation. So we took something like x squared and we added things to it. And recall that this 2 out here took the graph of x squared up to, and then the inside -1 here took it right 1 in the opposite direction of the sign. So this took this vertex point right 1 and up 2. And notice that the new vertex was at 1, 2. Well, notice that now we can determine if we have an equation written in this form, we can see what the vertex is. It's the opposite of the number in the parentheses, and then the same for the y value of the number out here. All right, so this is what this formula is saying, is if we have something written where we have a quantity in parentheses squared plus some number out to the side, the h is the x value of our vertex, and then the k is the y value of our vertex. We also have something called an axis of symmetry. And on this graph, the axis of symmetry is just the y-axis. It is a vertical line that divides the parabola into the two mirror images. So right over here, I could kind of make a dotted vertical line going through that vertex. And the equation of that vertical line is x equals 1. Remember from our linear stuff we had a little bit earlier this week, a vertical line has an equation of the form x equals a number, and that number is always whatever its points have for their x value. All right, so x equals 1 is the axis of symmetry right there. It's equal to the x value of our vertex. So, with that in mind, let's find each of these. And we don't have to graph. Let's notice it's written in this form where we have these parentheses squared. So we can pick off our vertex and we can pick off the axis of symmetry. So here, let's pick off that vertex. Opposite of this number here, that's 4. Same as this number here, that's 3. So our vertex is at 4, 3. Our axis of symmetry is always x equals whatever this value is here, 4. That's our axis. All right, so let's do the same things to the next one. Again, we can pick off that vertex opposite of this number, so -2, same as this number, -3. Axis of symmetry is x equals whatever we have for our x value, so x equals -2 is the axis of symmetry. Okay. So now let's notice the next one says find the vertex of this function. And unlike the function we had up here, it doesn't have this nice factored form. Everything's been multiplied out. And the majority of the time when we see a quadratic equation, it's going to look like this and not like this. So we have to do something else to find the vertex. So what we do is our first step is to use the vertex formula to find x. And our vertex formula, I'm going to give you now, I'll draw it on here, is x equals -b over 2a. So this is the vertex formula. Vertex. And you may remember when we were doing the quadratic formula during our first few weeks of class, it had an A, B, and C in it. All right, and it's the same A, B, and C we use for the vertex formula. So the number in front of x squared is A, the number in front of x is B, and the number out to the side is C. So this is exactly the same A, and B. You'll notice C is not involved. All right, so let's find the x value of our vertex by plugging into this. We'll have negative B, negative 6. And then on the bottom, 2 times A, 2 times 3. So on top, that's going to give me a positive 6. On the bottom, it's going to give me a positive 6. So the x value of this vertex is 1. Now that's only the x value, and we still need the y value. To get the y value, we take our 1 and plug it back into the x in our function. So we'll do our functional notation, f of 1, 3 times 1 squared minus 6 times 1 plus 4. And this is going to give me 3 times 1, so 3. This will be 6 plus 4. 3 minus 6 is negative 3, plus 4 gives me a 1. So my vertex is x value 1, y value 1. Okay, so let's do one more of using the vertex formula. So find the vertex of this one. All right, so let's start the same way. Negative b over 2a. RB is a negative 12, so it'll be negative 12 over 2 times a, 2 times 2. So that gives me a positive 12 over 4, which is 3. Okay, so that's the x value of the vertex. Now let's put it back into the function to get the y value. So f of 3, 2 times 3 squared, minus 12 times 3, minus 9. So this is going to be 2 times 9, minus 36, minus 9, or 18 minus 36 minus 9. And let's see, 18 minus 36 is negative 18, and negative 18, and negative 9 is negative 27. So our vertex is at 3 for x, negative 27 for y.